Hello everyone, welcome back to the channel. If you learned something new today and you find value in this presentation, please, I would greatly appreciate if you consider dropping a like and subscribe to the channel. This will obviously make it easier for other people that are into developing decentralized applications to actually find this content as well. So that would be amazing. So with that out of the way, let me ask you a question. Have you ever wondered how to deploy a fully decentralized web application? I guess you must be wondering this because otherwise you wouldn't be watching this video. So today we are doing just that using Solana's Shadow Drive and the Solana Name Service. These are two pillars of the strategy that I found actually does work to host a decentralized web application. So we'll kick off by exploring SNS and discovering how it simplifies the access to decentralized applications, making them easy to reach as any traditional website. Then we'll dive deep into Shadow Drive. I'll give you a little bit of an overview and basically talk a little bit about decentralized file hosting and see how basically it liberates our applications from having to use centralized hosting platforms like the traditional cloud providers like Amazon Web Services or Google Cloud or Azure, Microsoft Azure, things like that. But that's not all. We'll also tackle the challenge of preparing our web application to be uploaded into Shadow Drive. So you can see how simple it is, but it does require a little bit of preparation because Shadow Drive is kind of an object, sort of a distributed object storage system, and it doesn't cope well with folders. So we'll dive into that as well. And I think, whether you're a seasoned software developer or just curious about decentralized technologies, this session, I think, will equip you with the knowledge to elevate your web applications into the decentralized future. So let's just dive in. So this is the flow of what we are going to talk about in this presentation. The first thing to note is that I'm talking about Flutter here because this is the platform that I've chosen. Again, I've spoken about this in previous videos, but Flutter for me personally was a choice because I wanted to minimize the amount of time and effort that I was dedicating to develop for multiple platforms. I wanted to just have a cross-platform approach, so that's why I chose Flutter. But this, what we're going to talk about here is applicable to any web application that you might be using. You could be using one of the React sort of JavaScript React frameworks or any other JavaScript framework. It doesn't matter what you're using. As long as you're using a web application that you want to host somewhere, these steps are more or less kind of applicable to you as well. It doesn't have to be Flutter, but in my case, because most of the code is in Dart, Flutter build web is kind of the command line that you use to compile the Dart code into JavaScript. I already had some native JavaScript in that code because of the integration with the Phantom wallet. Again, this was something that I've discussed in my last video. So if you want to take a look at that, please check the last video about the Phantom wallet integration. And do let me know if you want to have more code snippets or examples, or even if you want me to post some code on GitHub that you can take a look at. I'm more than happy to do that. Once the app is ready, so you've tested it, it works, it's fine, then you need to run some Gulp tasks. I'll show you why and all of those things. Then once the gulp is done, which is a few seconds, you just basically upload to Shadow Drive. Again, I'll go into the nitty-gritty detail about how to install both Gulp and Shadow Drive, create a Shadow Drive account. And then finally, I'll give you a short little demo of the web app kind of working seamlessly. All of this whole presentation was actually one of the bullet points of the next video that I was going to make. So when I ran my last video about the Phantom Wallet integration, I said, in my next video, I'm gonna talk about these bullet points. This, like the first bullet point on there, was actually a demo. And then I thought, you know what, let's just do a video on decentralized hosting of a web application. And I think this is a topic that merits its own presentation, and hence why I decided, okay, let's do this one first, and then we'll talk about the nitty-gritty about like transaction encoding and how do you have your web application talking to the Solana blockchain, which will come in the next video. So some really exciting stuff coming in the next video. But this one is all about how to use a decentralized hosting platform to host your web application. So Solana Name Service. So SNS is essentially a decentralized domain name service built on the Solana blockchain. But what does that mean, actually? So just like how the traditional Web2 domain name system sort of works, which translates human-readable domain names like Amazon.com, it translates that into an IP address so that people don't have to remember IP addresses, because it would, human beings are not very good at remembering names, but they're very good at remembering, they're not very good at remembering IP addresses, i.e. numbers, but they're very good at remembering names. So SNS basically does the same thing, but it translates easy to remember .sol names into long, complex Solana wallet addresses. So that's basically what, in a very easy way, that's what it does. It's very, very similar to the traditional DNS, but it's for Web3. So what are the benefits of using SNS? So first and foremost, it simplifies the user experience. Instead of dealing with obviously a lengthy string of characters for a wallet address, you can use a simple name like yourname.sol. As you can see here, for instance, I believe I had, yeah, so that's the one. So as you can see, this is the name that of the application that I'm creating, and it's basically that name.sol. Very, very easy. These names are obviously, they improve memorability and shareability. So you can easily share this with your friends. It's not like a very weird sort of random assortment of letters and numbers, which makes it super hard for people to remember. Another significant advantage is that it's seamlessly integrated with the Solana ecosystem. So SNS domains are compatible with popular sort of Solana wallets like the Phantom wallet and decentralized applications as well, meaning that you can use these .sol domain names across various platforms within the network. Obviously, they need to be coded to be aware of those names, but a lot of them are already aware of those names, and it's easy to use them there. Each sold domain name can be represented as an NFT, a non-fungible token. This means that you have full ownership of your domain and you can transfer it like any other NFT. You have customizable records, so you can map your domain name to various records. For example, you can map this name that you've defined to your Solana wallet that you want to receive funds on. So when you give that name to someone, when they send funds to that name, you can define actually the wallet that you want to receive those funds on. This is cool. It doesn't have to be the wallet that registered the name, so it can be any other wallet that you have. But the other thing is also is that you can define other blockchain addresses in that wallet as well, which is interesting. So you can define it for Bitcoin, for Ethereum, for any other. So you can actually have this name associated with a bunch of different um, blockchain addresses, different blockchains, and you can map them to this name as well, which is cool. Again, this will only work if the applications that people are using to transfer that, let's say Bitcoin or any other thing to you, if they are aware of the .sol domain names. But if they are, then this is going to work, of course. And of course, you can, as we are going to see here in this presentation, you can actually you can define a URL, for instance, for a website, which is, guess what, it's going to be our web application. You can point this name to a URL as well. So this is great because now you can take this .sol name, you can put it on a Web3 aware browser like Brave browser, and you can just type this URL that you see here directly in Brave, and it takes you straight to the web application that I created. Or you could put it into Chrome, for example, which is not, unfortunately, but I think eventually, probably not long until they finally succumb to having to do it as well, because Chrome doesn't interpret sol names directly. I'll show you. It's a minor thing that you have to add there at the end to make it work with Chrome. Anything else that I wanted to say here? I don't think so. So, so this is how it looks like. So if you go to sns.id, this is kind of the screen that you would see. And then you just basically type the name of the domain that you want to create, or the application. You type it there. If it doesn't exist, you can create it, you can claim it. And obviously you need to connect your wallet to the website. And once you do that, you can map some records to that name. So as you can see here, so this is my created name, and I can map a bunch of records. As you can see, we also have social media stuff in here as well, which I've not really explored, but I've actually done it only for the URL stuff, but you can do it for a number of other types of records. So this is like a huge, this is a big deal. Like for Web3 developers, this is a big deal. And I will explore this further, some of this other stuff in here. And if I find something cool, I'll definitely make a video about that, and I'll share it with you guys as well. Right, so I'm not going to spend too long on this. It's a little bit of a why you should use it, but I was actually quite amazed because in less than 5 minutes, I had a fully working name, domain name. It cost me roughly about $20 to claim it in Sol. So, when I say dollars, it's basically the equivalent in Sol. So it was like, I think it was 0.11 or something like that. So at the time, at that price of Sol, it might be less now because Sol is more expensive. And if you compare it with the traditional Web2, so the upfront cost might be a little bit more expensive. Oh, by the way, the cost can be more if your domain name is shorter. So the shorter the domain name, the more expensive it can get. But for instance, for the one that I've created, it was only $20. So I consider that cheap, at least. But for Web2, for example, you could have something as low as $10, but then this is a recurring cost. So this is a one-time cost. This is a recurring cost. So that's not great, right? So the total cost of ownership of Web2 is actually bigger, much bigger than over the course of a number of years, of course, than the Web3 equivalent that you see here. So it's more of a lease model, as you can see here, compared to the SNS, which you basically can wrap in an NFT and trade it freely with other people. So you truly own your name, as opposed to the Web2 world, which basically they don't let you own anything. You shall own you shall own nothing and be happy. The meme that probably a lot of you will remember from seeing that everywhere, especially on crypto Twitter or crypto X in this case. Yeah, so I don't think I have. Let me just see my notes here. Yeah, I think I've said everything that I needed to say on this slide. Right, so next we'll utilize Shadow Drive, a decentralized file storage solution integrated with Solana. So Shadow Drive allows us to host our web app files in a decentralized manner, ensuring censorship resistance, which we obviously love, and high availability. So I know this is a really sort of busy slide, but I'll try and break it down in a simple manner. So using Shadow Drive to host files for our application is easy. You'll see that in a minute, but it's not that complicated. And I, initially when I started following, so the documentation that the Shadow Drive guys have created is actually pretty good. And I followed it step by step, and in a few minutes, in less than half an hour, I was uploading files, or even much less than half an hour, I was uploading files to Shadow Drive. So that's really the easy part. And I was actually referencing those files back once they were uploaded on a browser or anything like that. So I could upload images or a little bit of JavaScript code or anything like that, and it worked perfectly. So that's fine. But how about, like, the immediate thought that I had was, all right, okay, so this works for static files and for things like that, but how about something a little bit more complicated, like hosting a complete web application on Shadow Drive? How easy or hard is that going to be? So it's not as easy as just doing individual files, as you probably guessed from seeing my agenda and seeing me talk about Gulp and things like that. But let's just go step by step. So let's just talk a little bit about Shadow Drive first before we go into the nitty-gritty of the specifics about the challenge of using Shadow Drive for web applications. So just so you have, like, take a step back and kind of understand the big picture about Shadow Drive and why it's, so far I'm very impressed with this platform. So unlike traditional cloud storage services that rely on centralized servers, Shadow Drive obviously leverages a distributed network of nodes to store data securely and immutably. Very important. This means that our files are stored across multiple locations, ensuring data integrity and enhancing security, of course. Shadow Drive operates by utilizing a protocol called Ceph. I don't know how to pronounce this one. CEPH, an open source distributed object storage system that decentralizes data across a network of nodes. Solana is, and you can see those nodes here in this picture. So Solana is integrated as a ledger for managing the storage proofs, payments, and file operations, ensuring tamper-proof verification through program-derived addresses, PDAs. You probably remember PDAs from a few videos back when I started talking about Solana smart contracts. So I'm not going to go into too deep on this video on PDAs, but if you want to know more about those, please watch some of my earlier videos. When you upload a file, it is sharded and stored across multiple nodes in triplicate, as you can see here. And this obviously enhances redundancy, resiliency, and decentralization, of course. So Solana provides obviously a fast, scalable, and low-cost transaction confirmations for these types of operations, making the system resilient and trustless. As you know, in the Ethereum world, we used to have, and these are much older platforms that came before Shadow Drive, Arweave and Filecoin. I think Filecoin came first and Arweave came second. But obviously these platforms are good for Ethereum, but they're not really well integrated into Solana. So Shadow Drive is kind of the equivalent, but it's a much younger platform that started a lot more recently than the other two, which are much older. So it's much smaller market cap as well. I'm not going to say any more about this. So why choose Shadow Drive for kind of hosting our web application? So obviously we talked about censorship resistance, which is a big one. High availability and reliability, of course, because you have your files are kind of distributed across the network. You have seamless integration with the Solana ecosystem. So Shadow Drive, of course, is designed to work natively with Solana-based applications. So this means that you can obviously deploy the app more efficiently, take full advantage of Solana's high-performance blockchain capabilities. Cost-effective storage solution. So with Shadow Drive, we pay only for the storage that we actually use. The pricing is transparent and managed on chain, often making it more affordable option compared to the traditional cloud storage providers, again, like the AWSs of this world. Just so you know, they have a 0.05 US dollars per gigabyte per year. That's pretty cheap if you ask me. This price target is of course converted to Shadow, which is, I think it's SHDW, so Shadow, at the time of fee collection. So what does that mean? That means that when you let's say create an account, you need to have some Shadow tokens in your Solana wallet. At the time of recording, Shadow is actually pretty cheap. So you can buy very cheaply a bunch of tokens, and then you can pay your fees to the Shadow ecosystem by just basically having some Shadow in your wallet. And as I said, everything is currently, it's pretty cheap. You know, as I said, 0.05 US dollars per gigabyte per year. It's amazingly cheap. I don't think there is anything in the traditional Web2 space that is as cheap as that. Not even Arweave, not even Filecoin. All of those are way more expensive. Okay, so that's that. So let's go to the next one. So talking a little bit about the command line instructions that you need to know. So obviously first, in order for any of this to work, you need to have your Solana CLI installed. That's obviously super important. You need to also install the Shadow Drive CLI, and you can go to this address here to install the Shadow Drive CLI. Follow the instructions. It's super easy. I had no problem doing this like in a few minutes. Then once you have the Shadow Drive CLI, and by the way, I'm using the Mac OS. I don't know for Windows how easy the experience is, but I suspect it's the same as for Mac. You can create the account with the right size by basically just using this example command here. I actually took this one straight from the Shadow Drive documentation. And as you can see, this is the name of the command, Shadow Drive. So once you install the CLI, obviously this command will be available to you. So you can call Shadow Drive, create storage account. This is your key pair. So obviously that's why you need the Solana CLI installed to generate this key pair. But then you give it a name to the account, and then you specify the size of the account. For instance, for my application currently, because it doesn't use that much space, I created it with just 20 megabytes. and it's been working perfectly fine. But because it's so cheap, as I mentioned earlier, I could have easily created with 1 GB, and it's actually you can expand. So if you create it with 20 megabytes, I can extend it to a much bigger size. Obviously, I need some shadow tokens again to pay for the fees, but again, it's all very cheap. So I decided to start small and then expand or extend the size as I need more. So yeah, so you can get some information of your create. So once you create the account, if you want to verify if the account is created successfully, you can do this. You can just call Shadow Drive get storage account. In this case, for instance, I'm using my key pair here that I created specifically for this application. And by the way, you will see this RPC attribute. So one of the reasons I started using, in this case, the Helios RPC URL is because so you could try and call these commands without having this RPC. And when that happens, what tends to happen is that Shadow Drive will default to the mainnet sort of RPC. But that RPC, from my understanding, has some limitations. So it doesn't, probably to avoid, some form of DDoS attacks or, there must be some reason why. I'm not exactly sure why, but there are some probably security concerns or scalability. There must be something in there, but they're not allowing all types of requests to be serviced by the general sort of mainnet one. So it falls to others that are providing RPC services to provide a broader sort of a spectrum of RPC services. And this one for me, the Helios one, is working perfectly. I'm using the free version, so they have some paid versions that allow probably higher requests per second and things like that. So when I launch this application in production, I will probably want to go for the paid version of the RPC, but for the time being, it's like for development only purposes, it's fine to just do, the free version works perfectly fine for me. And then you have this one is a super important command, Shadow Drive upload multiple files. So this obviously, as the name implies, you go into a folder, run that command from that folder. As you can see here, -d dot basically means current directory. And then it goes and uploads all of those files that you have in that folder to Shadow Drive. So that's really, really one of the commands that I use the most. Now, there are other useful commands that I've used. The edit file. So edit file actually has a very unique specific meaning for Shadow Drive. So edit file actually is a replace. So that's why. So you always have the key pair as one of the things that you need to provide, but then you say, for instance, in this case, I was replacing the index.html of my web app. So I was saying, please replace this file here, which is, and this shadow account, by the way, is the long string sort of associated with your account when you create the account with Shadow Drive. And this is basically saying, please replace the file index.html in this address with this local file that I have here, using obviously this RPC. So that's a very useful command, because if you try to upload a single file with this command here that I have here, so this, and like this one, which does it for multiple files, this only works for one file. But this one here, I believe it returns an error when you try to upload a file that is already there. Like it doesn't stop. It continues, you can run the upload file command again for other files that you have there, and it will service that command. But the problem is, I believe it fails if the file already exists. That's why you have edit file, which is this one here. You also have delete file, does what you would expect. It basically just deletes the file. And finally, I've included this one here. It's not one that I use a lot, but it's useful. For instance, when you're using the Solana command line instructions. So if you do Solana balance, for example, you can get your balance, but it only shows you the SOL tokens in your wallet. If you want to get like the non-SOL tokens in your wallet, this is how you do it. So you do SPL token accounts. And then you say, in this case, yeah, I'm saying basically, give me the non-SOL tokens that are in my mainnet, associated with my mainnet account. And this basically lists how many shadow tokens I have. But it will not just stop at shadow tokens. It will give you all non-SOL tokens, I believe. So yeah, pretty useful, but I don't use it very often. It's just a useful thing to know. Right. So yeah, so we have this storage accounts. So effectively, all of this stuff that I've talked to you about, you can do it on the Shadow Drive portal as well. So you can create multiple accounts, and you can do this via the UI. It's a really good looking UI, as you can see here. So I created the account, and then you can upload files in there graphically without using the CLI. But I just prefer to use the CLI. But this is just another another way that you have at your fingertips to actually operate with a shadow drive. And it's just nice to know that this option also exists for you to use. Right, so this next one then, so let's talk about Gulp. But as I said before, so Shadow Drive is a great platform. So, from it's fast and it's intuitive, it's not complicated to use. But there is an important aspect to consider here. And the aspect is that the Shadow Drive currently does not support folders or directory hierarchies. So all of the files are stored in a single flat namespace. And for a typical web app, which relies on structured directories for assets, images, scripts, style sheets, icons, you name it, this obviously represents a challenge. So how does this impact our development and deployment even? You have to do two things. The first thing to know is that you have to adjust your file paths. So we'll obviously need to modify the web app's internal references to accommodate a flat file structure. This means updating links and source paths in our HTML, CSS, and JavaScript files, also JSON files as well, and ensure that they point to the correct locations after deployment. And then obviously the second thing is flattening the directory structure, which means we must reorganize our files into a single level directory. So every other file that you have in subdirectories, just copy them over to a single sort of directory so that they're all in a sort of flat structure. Now, I know what you're thinking. What you're thinking is, gosh, like doing this manually is going to be extremely time consuming and error prone. And you would be right in thinking that, because that's exactly what I thought. And this is why I thought about, okay, so we have to have an automated solution for this problem. So, and this is how I came across Gulp to automate the process of flattening files and updating all the necessary paths within our web application. And I needed a solution that was particularly useful for web, because so again, I'm using Flutter because I wanted a cross-platform approach for both web and mobile. For mobile, this is obviously not a problem because mobile is mobile. Mobile is going to be running on each person's device. However, for web, it's all in JavaScript, or let's say Dart code is converted to JavaScript in my case. So and these applications typically have subfolders. So hence why I basically needed a solution, an automated solution or a tool that allows me to flatten the whole structure in a typical JavaScript web application. And this is how I came across Gulp. So, so Gulp is basically a JavaScript task runner. It enables you to encode all of these repetitive tasks that you to perform. And of course, you wouldn't want, and this is why it's so important to automate this, is that you don't want to be replacing paths like manually. You don't want to be flattening files manually. This would be tedious, error prone, and all that, as I said. So you want an automated solution. The tasks are encoded in a file called gulpfile.js, and this is what I'm going to show you next. So before we jump into the code, I forgot I had a little help here to tell you how to install Gulp. So I had to install it with npm. Obviously, most of you that work on web apps are very familiar with this. So you just run npm install gulp CLI to get the CLI first. And then you run this command here to install the libraries. Then you create the gulp file.js at the root of your, again, in my case, at the root of the Flutter project, but you could be at the root of your web app project, doesn't have to be Flutter. And then run gulp from there. You can run gulp on its own, and it will run all the tasks that you have encoded in the file, or you can run gulp and then the name of the task, like, for example, gulp flatten. So I'll show you in a minute what that means. So this script creates, in my case, the script, what it does is it creates a new folder in the Flutter build folder called flat. So the Flutter framework, when it builds the web app, it places it under /build/web. And I created, so this script basically creates the flat folder in that build folder. Hope that's clear. Yeah, so here it is. So the gulp file, I'll try and explain this very briefly, but it's very, like, the code reads really well. It's practically English, so you can, even if you're not familiar with Gulp or how Gulp works, you go through this and you immediately kind of get the gist of what it's doing. So it starts off by importing some libraries. This one is important. Remember this one. So base URL in this case is the shadow drive base URL where all of your files are being kept. So every time you upload a file to Shadow Drive, and this is like a really important, interesting feature of Shadow Drive, is that when you upload a file, it always has the same base path, which is awesome. And what that means is it's predictable. Like, every single file will have this same base path. And this bit here is the account, like the account that when you create the Shadow Drive account the first time, that string, that long string, which I believe might be a Solana address, that string basically is your account. So every single file will follow that same base path, which is great. As I said, predictable. So it starts off by cleaning. First of all, it cleans the build flat structure. So this is so that every time I run gulp, I want the whatever is there just gets destroyed and gets rebuilt new, because I want those files to be replaced by whatever compiled version of my app I have at that precise moment in time. So that's that. And then copy binaries. So one of the things I've noticed when using Gulp, and this was just after I lost maybe an hour on this, like why on earth are my icons not showing correctly? So what I had this issue, which was when Gulp started copying all of basically taking all of the files in my, like the CSS, the JavaScript, the HTMLs, the image binaries, etc., etc. When it placed them in the flat folder structure, it was corrupting the binary files. And how do I know that? Because when I access those files, like say that I went into my local sort of browser and I navigated to those image files, I immediately started seeing that those files were corrupted. So I couldn't, so like the JPEGs, for example, were not showing. And I was like, that's weird, because there shouldn't be any manipulation of those files. But actually they were manipulated. So I think they were basically, what was happening was somehow, for some reason, the flatten process was writing the binary files with a different encoding format. So I effectively said, okay, for the binaries, please don't do any encoding. I just want you to copy them raw as they are. Don't do anything funny with them. And just copy them to the destination folder. That's what this is about. Then I set the base href. So this is obviously in the index.html in my case. So obviously it's important that the base href is going to become your base URL, which is, again, remember, the shadow drive base URL. So any other files will use this base href to refer to the full path of the file. So it's important that we replace that, because I think originally with Flutter the base href is like just / I believe. So this replaces that with the full sort of shadow drive URL. And now here is one of the most important sort of tasks, which is the flatten task. So it basically goes to all the files that are in my web app, and from all the folders, everything, including visible and invisible and hidden files as well. And it basically just takes them all out and just places them in the build / flat directory. So that's that. Now, this is super important. Update references. Basically, what this is doing, I don't want to spend too long on this, but you can pause the video if you want to see this in more detail. But effectively, what this does is it goes into each of these files. So in this case, HTML files, CSS files, JavaScript files, and it goes in there and starts replacing paths with the right one. So most of the time you want to do this for anything that is just say assets / something. So that needs to be replaced. Now, what that needs to be replaced with, it depends on your application. But effectively, this is, as you can see, this is the assets one. I have another one here for icons. And you will see, so this file, my Gulp file is not optimized at all. This grew organically as I was stumbling, because this Gulp file construction for me personally was kind of trial and error. Initially, I thought I had everything thought through with this first update references, but then this is iterative, the way you find whether the things are working or not. Like the image files example that the corruption of the image files that I've talked about. So initially I only had this, and then I start in the flatten one, and then I start to see, oh, images are corrupt. Okay, so I need to do something about that. Okay, fixed it. And then I had another one for manifest.json. So effectively, what I should have done is I should have included also JSON files as part of this update references, and this update references would have a lot more rules inside of it. But I didn't do that because I was kind of fixing it as I was testing it and fine tuning it. So this is another one for replacing some references in that JSON file. Again, another one for font manifest.json, another one for icons.json. So there were a lot of references. Again, I could have merged all of these in update references. I didn't need to have like separate tasks for these. But again, as I said, I wasn't trying to optimize. I was just quick and dirty. And as I was finding things that were not working, I was adding them separately. This also made it easy for me to just remove them if they were not the right thing, or update just that tiny little bit. But I guess I could have done it in the update references. Anyway, point is, this is not optimized, but you get the gist of what it's doing. Another one that I had like treated separately was this service worker.js. Again, I could have probably put it in the update references, but all of these are basically doing the same thing. They're going into the files and replacing file paths here and there to take into account the new flat structure. That's what it's doing. And then the final one is this one, which basically it's just the running. So this defines the tasks, but they don't really run until you do this. So you call the clean one first, then it flattens, then it copies the binaries. Remember, the flatten one had negate. So if I go back to the first one, no, where is it? Yeah, as you can see here, for binaries, it was basically excluding, as you can see, the exclamation mark there. So it's basically saying when you flatten, don't really take the binaries. We'll do the binaries separately. And that's why you see that exclamation mark there. And that's why you saw that I had the copy binaries as a separate task, right? All right, so let's access our web application. So I'll show you the web application. Just bear with me a second. I'm gonna go to the Brave browser. Right, as you can see, so first things first. So if I go to this address, as you can see here, it recognizes immediately my web app. In fact, if I click sign in, it actually lets me sign in. And you can see the address there. And if I disconnect, it goes back there. This one is actually creating an account because it's a new address that I just created just before I started recording this video. But if I go to, say, here, and I go here, as you can see, so in this case, this is the address for a Chrome browser. So as you can see, the difference is you have to add -domain.org. That's it. That's the only difference. Everything else is the same in a Chrome browser because Chrome is not Web3 aware, while Brave is. And in this case, I have Phantom Wallet also installed. And this wallet actually has gone through the initialization process. So if I click sign in, as you can see, it goes straight to, it doesn't show the create account button because this user with this wallet, which is different obviously from the wallet in the Brave browser, this user already has an account created with my application, and therefore it goes straight to the home page, which in this case it just shows the products. And as you can see, it's a very easy application. By the way, so this is this, oops, let me just unlock. All right, so this, as you can see, I have some shadow tokens in there, some Solana. And if you look at this address, it's exactly the same as this, right? That's the connected wallet. One of the things that you can see, so I have some Solana in here, not a lot of Solana, so I cannot buy a lot of wine. So I'm gonna just say I'm gonna buy one here. Let me see how much Solana I have, 72. So I can buy actually 2 bottles with this. And now I can place an order. Now, I already had a shipping address entered. If this was the first time that I was doing it, would ask me for the shipping address, but because I already have one, it was encrypted and then stored in the blockchain in my PDA profile. And as you can see here, it's basically saying, okay, you're buying these 2 products with this much money. So this equates to about 0.46. So we can place the order. Ooh, request blocked. Okay, proceed. Oh, this is interesting. I've not seen this before. Ah, I know why. This is happening because, let me just show you. This is happening because I am actually connected to mainnet, and this application is connected to DevNet. So this is why. So I would, in order to make this work, let me just disconnect here. In order to make this work, I would need to, this is a cool thing really. I would need to go here and then settings, and then go developer settings. I would need to enable testnet, and now it's in DevNet, right? So that's fine. Now you see this here, this yellowish thingy. So you need to sign in again. Right. So let's try this again. So how much money do I have on this one? Oh, it doesn't show. Oh no, but I have 6 SOL. So that's more than enough money, I guess. So let's try again. Right. Okay. So place order. Oh, that's interesting. It's still, and this is why. Okay. Interesting. Very, very interesting. Okay. Anyway, I was able to get it through. I have to see why those pop-ups are coming up, because that's new. Never seen that before. Yeah, so you see the transaction ID of the processed order, and now you can, this sometimes takes a few seconds. For DevNet in particular, I've seen it sometimes it doesn't want to show you the transaction details for some reason, but this is the transaction uh, ID, I guess, and you can click there. Oh, there you go. So this one is actually working today. So you're in DevNet, as you can see, and it shows the amount of money that you paid for the 2 bottles of wine. And as you can see, the 0.46 SOL, which is, if you can remember, it's roughly the amount of money that we talked about. Right, so after this very weird demo, because of all of those errors in the wallet, sorry guys, made you waste a little bit of time. Let's go back to the slide, shall we? Right, so we're almost done. So I just wanted to reiterate some of the benefits. I should have actually, I will probably do a short video, not like an hour-long video, but like a really short video about like the benefits of developing with Solana. But I couldn't help but actually do it a little bit now, but I will probably mention this again in an upcoming video with a lot more details and comparisons with the Web2 world. I like to do these comparisons because obviously, as most of you I didn't start my software development career in Web3. I started in Web2, as 99 probably percent of the viewers in this channel. But um, these are some of the things that I found really outstanding of developing with Solana. You have an identity platform already built in, so authentication and authorization are kind of like there without any extra services or like AWS Cognito or any Azure B2C or whatever it might be. So there are like tons of identity platforms. Guess what? You don't need any of those. You don't need that the time and effort to integrate them or the cost that which is not insignificant to use them. Um, all of that is built in because we have a wallet and it's way more secure. So secure storage, of course, transaction capabilities. So I, if you've worked with databases, you know what atomic transactions actually means. And that capability is also present with Solana. It's very robust and resilient, obviously, against DDoS attacks because it's all fully decentralized. Fast payments, it's one of the key features of Solana, so it's super fast. And with Fire Dancer coming, it's going to be even faster, 1 million TPS. It's going to be crazy. And crazy cheap as well with the new storage accounts taking advantage of compression. Then you have an immutable ledger, of course, which is a transparent and unchangeable transaction history. This is a transparency that not many Web2 counterparts can aspire to have. We have it out of the box straight away available. And access control is really easy to do it with Anchor-based Solana smart contracts. Again, all of these features reduce the need for traditional centralized and often expensive web services that we will have to use separate solutions for the Web2 space. But for Web3, these are kind of built in. They're part of the system. So looking ahead, all I have to say is thank you for joining me on this journey, deploying a decentralized web app on Shadow Drive using the Solana Name Service, SNS. I hope this has inspired you to dive into decentralized development. I think more progress, this is a general comment, needs to be made in the area of front-end decentralization, because most of the time, a lot of when people talk about decentralized applications, they're really talking about decentralized from a backend perspective. So yes, there is the Solana smart contract. That's the decentralized element of it. But a lot of the other elements, like the front end app and some of the other services that the app consumes, are all centralized. So it begs the question: when you say that you have a DApp, is it really like what? Obviously, this is not either centralized or decentralized. I talked about this in one of my previous videos. Decentralization is a spectrum. It's a journey that you can travel, and as decentralized technology evolves and decentralized options mature, like decentralized name services, there was a time that this kind of stuff didn't exist, or decentralized file storage solutions like Shadow Drive or Filecoin or Arweave, like all of these things didn't exist at one point in time, so we couldn't actually use them. But as more decentralized options start existing, we can start using them, and therefore that means that the ultimate goal of having a fully 100% decentralized solution is quite powerful and quite, at least for me, quite rewarding to try and achieve that level of decentralization. And the simple web application, which is not as simple as it looks simple, but under the hood, it's actually doing a lot of stuff. As you can see, it's doing payments, it's doing file storage, decentralized file storage, it's doing decentralized ID and authorization and authentication. It's saving metadata in the blockchain that is associated with your account. So it's doing quite a fair amount. And all of this stuff is being done in a decentralized fashion. There are no centralized components in this whatsoever, and that's great. And I hope to keep it that way. I think scale under load is one of the things that I'm still worried about, but I will do some performance testing to kind of dispel those concerns, let's put it like that. Yeah, so feel free, obviously, to reach out with any questions that you may have once you see this video, and share your own projects. Leave a comment down below if you're working on a decentralized application, and if you're exploring decentralized hosting for your web application, which is what we discussed today. And yeah, looking ahead, as you can see in these bullet points, we'll be talking about topics like transaction encoding and querying the blockchain. I will also demo the app for web and mobile, but more for mobile now, because obviously you've seen the web now. And yeah, as I said in the very beginning of the video, if you lasted this long, please don't forget to like, subscribe, and hit the notification bell so that you know when my next video is posted. And yeah, stay empowered and stay decentralized. Thank you very much for watching. Goodbye.